Okay students, let's continue with the same concept, intensive and extensive properties, that which we are discussing in the previous previous class. We are discussing intensive property. What are intensive property? Let's begin and let's rewind it again in a brief. The property which does not depend on the quantity of the matter present in the system is called intensive property, or simply we can say the property which do not depend upon the quantity of that substance. Whatever the quantity of the substance, the property remains same, whether you measure the density of 1 gram of substance or measure the density of 10 gram of substance, the density remains same. The property density remains same of 1 gram of substance or 10 gram of substance. That is why it is called as an intensive property, because it does not depend upon its amount or quantity. Okay, proceed to the next property, that is extensive properties or extensive property. The property that does depend on the quantity of matter present in the system is called extensive property. That means here, unlike intensive property, extensive properties depends on the quantity of the substance. Whether you take for example, if you take some quantity of liquid, 1 liter of liquid, and in another container there are 2 liter of liquid, and if you are asked to take the weight of these two substances, liquids, same liquids but in different quantity, obviously we can see that they are having different mass. Mass is the extensive property. Okay, let us see some examples of intensive and extensive property. Here is the list of extensive properties. Energy is an extensive property, means greater the amount of substance, greater would be its energy. That is why energy of the substance depends on its quantity. Similar way, entropy, one of the thermodynamic properties, gives energy, length, mass, particle number, number of moles, volume, electrical charge and weight. These are the properties which depends on its quantity. That is why they are called extensive properties. And this is the list of intensive properties. There are so many intensive properties: chemical potential, concentration, density. Okay, concentration. When we talk about the concentration, concentration is nothing but the amount of solute present in the solution is called concentration. And greater the amount of solute, greater would be the concentration of solution. Means the concentration of any solution or substance depends on the quantity present in that solution. Okay, if we make two solutions in which in one solution we dissolve 5 grams of sodium chloride, that is salt, and in another solution of same quantity if we dissolve 10 grams of sodium chloride, then the second solution would be more concentrated than the first one, because the concentration of the solution, that means the second solution would be more concentrated. But if we measure the 1 ml concentration or 10 ml concentration, the value would be same. For example, don't get confused here. I was trying to tell you the definition and how different solutions of different concentrations are formed. Okay, here concentration is taken as an intensive property, not as an extensive property. Suppose you are provided with 1 liter of particular concentrated solution, for say 1 normal solution. Okay, 1 liter solution is there, out of which the two students are given, one solution is given 5 ml of the same solution, and another student is given 10 ml of same solution, and they are asked to measure the concentration of these solution by a conductometric or volumetric titration, then you will find that at the end of the practical both the solution will have the same concentration, though we have taken we have given the different quantities of the solution. Okay, that is why it is called intensive property, and these are the another examples of these intensive properties. Okay, here are a few more intensive and extensive properties. The examples of intensive properties: temperature, pressure, density, boiling point, surface tension. Whatever the quantity of the substance, the surface tension will be remain same. Refractive index, viscosity, and freezing point. These are the important properties, intensive properties, and these are the extensive. Mass depends on the quantity of the substance. Again, volume. Greater the quantity of the gas, greater would be its volume, whether it may be a gas or liquid. Okay. Internal energy of the substance, that depends upon the quantity. Greater the amount of substance, greater would be its internal energy. Enthalpy and entropy, these are the thermodynamic properties, and which also depends on the quantity of the substance. Let us proceed further. Okay. The another concept in this chapter is thermodynamic processes and their types. Okay, before going for the types, let us try to understand what is meant by a process. I would define the term process as it is an operation by which the thermodynamic system changes from one state to another state. That operation is called a process, or any operation or any action by which we can make the system to change from one state to another state. Now here is the big deal. What is meant by state of the system? That we need to first understand what is meant by state of the system. Here, to understand the term process, let us see state of the matter. As we know that matter exists in three states: solid state, liquid state, and gas state. Okay, conversion of solid substance to liquid substance, that process we call it as melting, and conversion of liquid to gas, it is called as a boiling or vaporization. Okay, during how can we convert the solids into liquid? By providing simply heat, or this process is called as a melting. Okay, melting is a process, an operation by which the system's states changes from solid to liquid. Okay, this process is called operation is called a process. Okay, again, liquid to gas, by providing the heat from the external resources, we can convert the liquid into gaseous state, that is the evaporation. This is the operation by which we are converting the liquid, is getting converted into gaseous. Now let us have a look at the types of thermodynamic processes. There are 5 thermodynamic processes based on which property of the system remains constant throughout the process. Depending on this fact, the processes, thermodynamic processes, are classified into 5 classes: isothermal process, adiabatic process, isochoric process, isobaric process, and cyclic process. Let us see each process in detail one by one. The first is isothermal process. Okay, first of all, let us try to understand what is meant by isothermal. Okay, again, this is a combination of 2 words, isothermal. Here iso stands for constant and therm stands for temperature. Let us say temperature. Okay, constant temperature. We know what is meant by process: an operation by which system changes from one state to another state. Okay, now we can define the isothermal process as a process is said to be isothermal if the temperature of the system remains constant during each state of the process. For an isothermal process, delta T is equal to 0. Okay, now I will explain it in a simple way. Now suppose this is a process, A is converting into B. this is the system in one state, the system in another state after completion of the process. Okay, initially the temperature of the system in its initial state is measured at T1, and after completing the process the temperature of the system is T2. Okay, if at the end of the process, thermodynamic process, if the T1, the value of T1 and value of T2 is equal, then and then only we can say the process is isothermal, because the temperature of the system remains constant throughout the process. That is why this process is said to be isothermal process, or in a simple language or in a simple words we can define the isothermal process as the process in which the temperature of the system remains constant, remains unchanged throughout the process, is called isothermal process. Okay, that is why the difference between here, whether you can see or not, I don't know. Therefore, if the T1 and T2 are same, means the same value, suppose T1 is 25 and T2 also 25, then T1 becomes equal to T2. Now delta T is nothing but the difference between the temperature of the system in its final state and initial state. Means T2 is the temperature of the system in its final state and T1 is the temperature of the system in its initial state, and the difference between these two is taken as delta T, or delta T is here I have written delta T is equal to always T2 minus T1. T2 is the temperature of the system in final state, means after completion of the process, whatever the state of the system, that is considered as final state, and T1 is the temperature of the system in its initial state. Okay, if these two values are same, then obviously this delta T, that is the difference between temperature of the system in its initial and final state, would be 0. Okay, have you understood? I hope you have understood it thoroughly. Now the another type of thermodynamic process is adiabatic process. Adiabatic means the heat of the system remains constant throughout the process, that is called as adiabatic process. In simple words, I would like to define it rather going reading all the things here mentioned here. Okay, adiabatic process, the process in which heat energy of the system remains unchanged, remains constant throughout the whole process. Means the heat of that system, suppose Q1 is the heat of the system in its initial state and Q2 is the heat of the energy in its final state, and Q2 minus Q1 is nothing but the difference between the heat energy of the system in final state and system in initial state. If heat remains constant, such processes are called adiabatic processes. Means here delta Q is equal to 0. In the isothermal process, delta T, that is equal to T2 minus T1 is equal to 0. And in adiabatic process, since the Q1 is equal to Q2, hence difference in heat energy would be also equal to 0. Understood? Heat energy remains constant here. Something is given. Okay, this is the system in its initial state and it converted into in the final state, that is A is converted into B. A is the initial state of the system, B is the final state of the system. Here changes occur. While converting from A to B, the pressure of the system changes from PA to PB. Means PA is the pressure of the system in its initial state, PB is the pressure of the system in the final state. Similarly, V1 and V2 are the volume of the system in initial state and in final state. But here, though the pressure and volume are changing during the process, but heat energy remains unchanged. That is why this process is called adiabatic process, the process in which delta